Remember I was telling you that I'm going to show you a kind of a sample data set, right? And then we will try to apply all the processes which we saw, right? So, please don't forget, we just discussed about decision tree and why it's actually needful. So, if you want to actually visualize how a particular problem can be solved by using a constraint. So, what's the constraint now? Which one is my root node? That is my constraint, right? So, we can actually solve this using a decision tree. And if you check, even in data modeling, on machine learning, or data analytics, most of the problems are solved, classification problems, okay? They are solved by using decision tree. Many of them. Even there are variants of that also where people go and use random forest. That is okay, a kind of, it's not part of the syllabus now, but if you remember, almost every problem, almost, I'm not saying all, okay, I'm saying almost. So every problem can be modeled using a decision tree. And we've seen this, right? Just to refresh your mind, we saw two major types, right? Where we had CAT, classification and regression trees, which uses your Gini index, and we have defined what Gini index is. And then another one, ID tree, which stands for iterative dichotomizer. So your class is purely on ID tree. So ID tree for me is cumbersome because you will understand when we start solving this. See here, we have about 14 rows, okay? So you can see it from there, right? Using the ID number, about 14 rows, and how many attributes or how many features are here? So if you want to take entire thing, so you see 1, 2, 3, 4, 5, 6. But please, okay? Do we need the ID number? Do we need it? We don't need the ID number, right? So, and I've not given you instruction on what to do. So, my instruction is, given this tree now, I want you to, given this data set, I want you to decide whether tennis will be played or not, based on these conditions. So, what you have to do now is, you need to find out what influences playing of tennis. What is it? So this becomes our predictor class, right? So this now is what decides. So what we can do here is, we don't need serial number. You think once again, will this have any effect? No. So I'm going to strike it out. So I strike out this. So how many features are left? How many features are left? 1, 2, 3, 4, 5. But wait a minute. This is our predictor, right? So this is where the emphasis is. So I know that now I have what? 4 features. 1, 2, 3, 4. Getting back to our decision tree, the next question arises, which one is my root node? Where should I start from? Should I start from Outlook and then consider all the other attributes of Outlook? Or should I start from temperature and consider all the attributes of temperature? Just in case, Outlook has 3 more attributes: sunny, rainy, and overcast. And if you check, sunny, overcast, rainy, right? So now you go to temperature, hot, mild, cool. It's okay. See, somehow we got the data set, right? So we don't want to say whether this data set is a true representation of a problem which can be solved with a decision tree. We have to try, right? So we cannot just conclude without trying. So again, we look at humidity. You have other ones, high, normal. Okay, so only 2, high and normal. We look at windy. Windy can be weak, strong. That's all. Again, 2. And you have your play tennis, yes or no. So let's recall how we solve this. First step, you have to compute the entropy for the entire data set. And you know the formula, right? Fine. So next, for every attribute or feature, say example, we have taken Outlook. Let's start from the first one, okay? So what are the attributes of Outlook, or what are the features? Sunny, rainy, overcast, right? So for every attribute of this Outlook, we have to calculate their entropy. So since it's a subset of the main entropy, please remember the entropy of the entire set is designated as entropy of S. Entropy of the subsets is designated as entropy of A. So for the entropy of S, we are going to use entire sample. So for the entropy of A, we are going to use a more reduced table, and you will see that now. After that, we calculate the average information gain. We calculate the gain for the current attribute. So we pick the highest gain attribute. And since it is iterative, we repeat this process of dividing and checking, taking out the one which has the highest information gain until we arrive at a pure leaf. So I'm going to wipe this now, and enough of talking, we get started. All right. So first thing what we have to do, we need to consider how many positive examples are there. You have to tell me. Please, I still request all of you to somehow pause the video, start solving. Afterwards, you just cross-check. See, if you check if you talk to your seniors also, we do this in class, right? So I want you to pause the video right now and take your pen and paper. Don't say, okay, I'm wasting. Actually, even I wasted time writing this, right? So why can't you waste that time and write it? Please remember, we are not wasting time. What you call wasting time, see, we actually trying to, reinforce whatever we have learned. So don't call it waste of time. Okay, you write this, take a sheet of paper, and let's solve this together. So the first step, we have to compute our entropy for the entire data set. So we start by this entropy. So step 1, right? So I'll call it step 1. I hope you can see the board, please. So step 1, we calculate the entropy of S. Okay, so because you were not able to see the board, I've decided to rewrite it again. So if you see here, we arrive at this, all the positive examples, we got 9 of them. You can check again, you can cross-check, okay? And then for all the negative examples, we got 5. So what's the sum of them? P plus n is what? 14. So let's plug in the values here now. So we have minus p upon p plus n into p upon p plus n log base 2 minus n upon p plus n into n upon p plus n log base 2. So we solve this, and then we are able to get 0.940. Now, please remember, this is the entropy of S. So what do we have to do next? According to algorithm, so we move to now this enters step 2. So in step 2, it says for each attribute, for each what? Attribute. So for each attribute means what now? So say for each attribute. What do you think we want to compute? You guessed it right. We want to compute entropy of A. So for each attribute, say now we have to choose, what are the attributes here? Outlook, temperature, humidity, windy. Outlook, temperature, humidity, windy. So let's take now outlook. So if we take outlook, what are the entropies of A now? Entropies of A means what? The subsets or subgroups of these attributes subgroup of this attribute outlook, which is sunny, overcast, and rainy. So we need to calculate the entropy of entropy A for what? Tell me. Sunny, overcast, and rainy. Overcast and rainy. So how would this be possible if we don't make a smaller subset? So what we do now is we make small tables. So here I have outlook and I have play tennis. For which one? Outlook, play tennis for sunny. So please tell me, sunny, how many sunnies can you get there? 1, 2, 3, 4, 5. Right. Sunny, 2, 3, 4. Sunny, 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 and sunny. Now, let's check their equivalents. Now, if we go to play tennis, for the first sunny, it was no. Second sunny, again, it was no. So, first sunny, nahi. Second sunny, nahi hai. Third one, what do you have for sunny? Please go with me. Sunny, yes. No, sorry, that was rainy. Sunny, no. Sunny, yes. And sunny, yes. So I have no, yes, yes, right? I have no, yes, and yes. So you see the reason why I want us to do this together. I hope you can see this. So this is for the smaller subsample of what attribute outlook. Now, again, see, I need for overcast and I need for rainy. So let me try to fit the tables here. Next one, this is for overcast. Oh, I think you won't be able to see if I go that way. So sunny, I'm going to reduce this small again. So next will be what? Overcast. Now I'm going to compress it, okay? Just bear with me. Overcast, and the last one will be rainy, so that you'll be able to see, okay? So again, so this is outlook, as you already know, and then this is play tennis. I'm calling it PT. This is again is outlook. I'm calling play tennis PT. 1, 2, 3, 4, 5. Again, 1, 2, 3, 4. I'll tell you why. See, I know that total number of records here, or rows here, or samples here, okay, they are 14. I've taken 5, right? One will be 5, another one will be 4. Ashte, fine. Now let's go to the one, I think. Now the next one is what? Overcast. Overcast, let's see. 1, 2, 3, and 4. Overcast. 1, 2, 3, and 4. And I know that all the overcasts are yes, 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 yes. So I'd go here, overcast, yes, 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 and yes. So this is overcast. Right. Now, what is left now is what? Rainy, right? So obviously rainy will be 5. Yes, I hope you agree to that. So rainy, 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 rainy. Now, let's check the equivalence, okay, in play tennis. So let's go there now. Rainy, the first occurrence of rainy is yes. Second is yes. So let's put them before we forget. Yes, yes. Now, third of rainy is nay, no, fine. The fourth one, rainy, is yes, and fifth is no. So we have yes, and fifth is no. So we are going to calculate next entropy of what? A, right? That is entropy of what? Outlook, no? That is my A. What is that? Respective value of the outlook, right? So the first one, what we have to do is entropy of sunny. Are you there? Fine. Please, the formula is still there, okay? It has not changed. So we call it entropy of outlook. So permit me to use something else. Entropy of outlook equals, let's plug in the value now, sunny. So what do we have? So sunny, how many positive examples are there? Please be very careful. Remember now, when we are calculating the sub-samples, we cannot use P plus N of the entire data set. That's why we made this table, right? Fine. So let's check now, how many positive samples are there? So I'm going to put it here, plus positive. How many of them? Quickly. 1, 2. So obviously, negative samples will be what? 3. Which is what? Minus 2 upon 2 plus 3 is 5 log base 2 into 2 upon 5. Then minus negative samples, 3 upon 5 log base 2 upon, again, 3 upon 5. Okay, so grab your calculator and punch the stuff. Okay, evaluate this quickly. You will see it boils down to 0.971. We have to repeat this again for what? Outlook, right? Outlook equals what now? Rainy. Rainy. So for rainy, let's go there quickly. So positive samples are 3, negative 2. Please don't get confused now. Please look here. Here positive samples were 2, negative 3. Here is just the reverse, right? So positive samples here will be what again? P3. P positive is 3. P of negative is 2. Now, same thing here. We now see minus 3 upon 5 log base 2 of 3 upon 5 minus then 2 upon 5 log base 2 of 2 upon 5. See, don't you think this will be the same answer? I mean, if you compute this, don't you think it will be same? Are you with me, guys? You check. It's going to be the same. So we have 0.971. Now, the last one, I mean, for this subset is outlook of what? Overcast. So, since there are no negative examples, right? So, only positive are there. So, we have what? Minus. So, what do you get now? 4 upon 4 is what? Minus 4 upon 4, you tell. Is 1, right? Log base 2 of what? 4 upon 4. Minus, the rest is 0 only. No, we are multiplying, so this is gone, right? So, if you check minus log 1 to base 2, you will get 0. Fine. Here we calculate what now? Average information entropy. So calculate now. See, this is lengthy as you can see. So we calculate average information entropy. Calculate average info entropy. So how do we calculate this? If you remember that formula, right? It says I of, remember, attribute, right? I of attribute. So I of what's the attribute now? Outlook equals what? We saw summation. If you remember, we saw this sign. Summation of Pi plus Ni upon P plus N. Did you remember this? Into the entropy, right? Did you remember this? So this we have to expand now. Okay? So let's expand this formula. This becomes P of what now? See, P of what? Sunny, rainy, and overcast, right? So we are adding them. So that is summation. So this becomes P of sunny plus N of sunny, okay, upon, please remember, upon P plus N, that was what we saw, okay, into the entropy of what? You guessed it right. Entropy of sunny. And that entropy of sunny is from outlook equal sunny. Did you agree? Yes. Plus is summation. Same thing we have to repeat, P of what? P of rainy plus N of rainy. I'm taking pains to write this so that you also do same. The more you write it down, the more you remember. P plus N into the entropy of, again, outlook equal rainy. That's not over. Plus the last one, P of overcast plus N of overcast, okay, upon P plus N. I hope you can see the board. That's why I'm also mentioning it alongside. Into entropy of outlook equal what? Overcast, right? So this is done. We have to plug in the values now. Okay, I believe, see, at this stage you have memorized the formula, right? So let's move on to plugging in the values. Now the question is, when I say this, you know what I'm picking, right? So how about when I say P plus N? P plus N, I'm talking about the entire data set. So you have to use upon 14. Is that clear? Fine. So let's proceed. So I'm going to wipe this, and again we continue. So the first one, which is 2 plus 3 upon 14 into what? Entropy of outlook equals sunny. Go back there. Entropy of outlook equals sunny, 0.971, right? 0.971 plus, so we get to this now, rainy, which is again 2 plus 3 3 plus 2 rainy. 3 plus 2, please remember, positive samples here were 3, negative 2, okay? So 3 plus 2 upon 14 into, again, go back, rainy, 0.971. Okay, so I'm not going to go beyond this because you won't see the board, right? So, again, plus the last one for outlook, right? So, for outlook, we had P plus N, and remember, the entropy was 0, right? Did you remember that? The entropy was 0, so I don't want to do this. Why? If I multiply anything by 0, okay, for the purpose of you guys, I will do it. 4 plus 0 upon 14 into 0. Whatever you get and multiply by 0, that disappears. So let's evaluate this. 0.693. Now, this is done. What have we calculated? The average information entropy. So what we need to get now is what? Information gain. So calculate information gain. So info gain, I'm going to abbreviate it, okay? Is the difference, right? Remember, entropy of what? You guessed it, right? Entropy of S minus, good. The average information entropy, which is I of the what? Attributes, which is what we just computed here. So what is the entropy of S? 0.940. So gain of outlook equals entropy of S, 0.940 minus the average information entropy, which is what? 0.693. Quickly, tell me what the answer is. So what do we get now? 0.247, which is 0.247. But that's not over. This is just stage 1, or first step of the problem. We are done with what? Outlook, right? Attribute equals outlook. What happens to temperature, humidity, and windy? That is an assignment for you. So, what you have to do, please listen. I'm going to give you the answer. You have to trace it and check whether there are discrepancies, okay? Next, repeat for other attributes. Attributes are known as features, okay? Or columns, that's it. Or columns, okay? So, you have to do this for other attributes. What are the attributes now? Temperature, humidity, and windy. That is for temperature. So, in temperature, remember we have sub-attributes, I mean, for you take like this, okay? Temperature, play tennis. In temperature, play tennis, you have to have 3 sub-tables again, which includes hot, mild, and cold. So hot, mild, and cold. Same thing. That's why I left this table here. Please remember, in place of Outlook, you substitute temperature. Okay? So you say temperature, play tennis. So first one, subset will be hot. Find how many instances of hot are there. Next, temperature, play tennis, mild. Lastly, temperature, play tennis, cold. Okay? Once you are done, you go and compute the what? Average information entropy. And finally, the information gain for that one. So I've calculated the gain, which is 0.029. Even if you don't see it, but I just mentioned it now, okay? 0.029. Now, after that temperature is over, you have to repeat the same process again for humidity. So you repeat for humidity. Make some subsets of that also. And for humidity, you have high and normal. So for high, you make again. And for normal also, you make another table. Okay? So same thing. Humidity, play tennis. Okay? For humidity, high. Then again, humidity, normal. Humidity. See, please remember. Humidity, play tennis. Humidity, play tennis. This will be for high. That will be for normal. Okay? Fine. 0.152. So this is the gain for that. Okay? So 0.152. And lastly, you have to compute for windy. So windy. So in windy, what do we have? In windy, then you have strong and weak. Again, you repeat the same thing. Strong and weak. So, and again, you calculate, follow the same process. Calculate the average information entropy. Calculate the information gain. And at the end, the information gain boils down to be 0.048, which is 0.048. Now, you enter step 4. Okay? Sorry. Yeah, you enter step 3, please. You enter step 3. The step 3 says what? Pick the highest gain value. Right? So, for me to pick the highest gain value, let's put this in a table. So, I'm going to put it here now. So, please look here. So what we'll have now is, I will call that attributes and the gain. So here I have attributes, and here gain. See, why am I putting it in a table? So it becomes easy for me to backtrack, right? So the attributes were outlook, if you remember, temperature, humidity, and windy. If you remember, outlook, temperature, humidity, and what? Windy, right? So, why put them into their respective values? Outlook was 0.247, 0.247, 0.247. Next, temperature, 0.029, 0.029. Next, windy, 0.048, 0.048. And lastly, humidity. Humidity, 0.152. And lastly, windy, 0.048. Right? So, everyone knows that the one with the highest information gain becomes the root node. So, which one has the highest information gain? That is Outlook. So, I circle it now. So, with this, I'm going to leave you at the first stage of the tree. Okay? I will leave you at the first stage of the tree. And I will let you walk your way down to see if you'll be able to get the pure leaf nodes. Right? So, what I will do now, I will erase this and then let's start tracing our tree. So here, we got this, right? So what we have to do, we now take our Outlook to be the root node. Hope that is clear. If you have any more doubts, feel free to get in touch with me. Then I will explain it again. All right? So our Outlook now has become our root node. I hope I can be able to fit it in this. So Outlook, no doubt. Now we know for sure, we know partially if a word like that exists. Okay? We know for sure that Outlook is our root node. Now, Outlook has other attributes, right? Sunny, rainy, and overcast. So, fine. So we branch it now. Sunny, Now, rainy and overcast. So why did this fellow put overcast at the center? Simply because I know that these two requires branching and this doesn't require branching. It doesn't matter, okay? You can put it here also, but just think of it. If I put sunny here and rainy here and overcast there, right? So it doesn't look nice, no? So I try to balance the three, right? So why do I say that overcast doesn't require branching? Because if you check, overcast has only one instance, which is positive. So overcast has gotten to the pure leaf node, which is yes, katam ho gaya. So we don't need any further splitting, right? So this is my pure leaf. No further splitting, right? Now, how about sunny? If I go to sunny and rainy, so I need to know which one should come next, right? So that is where I will enter step 4. See, sunny and rainy. Why? If you go to sunny, you have yes, no. You go to rainy, you have yes, no. So I need to split these two. So then these two now need further splitting. So they need further splitting. Needs, I hope you can see the board, needs further splitting. Now, what we do is, again we repeat the process. So the next table will look like this, attributes and gain. I'm just giving the value so that we finish the tree, okay? Attributes and gain value, okay? So what are the attributes now? What are the attributes? Don't tell me Outlook. Outlook is out only, right? So we have temperature, humidity, and windy. So temp, humidity, and windy. Now, so in temperature, I'm just giving you the gain value, the 0.020, 0.020. Then we pick the one with the highest information gain, which is 0.971. So, take it quickly. So we put here humidity, right? Now, humidity, what are the possible attributes? Subsets of humidity. Go back to your table, You have only high and normal. So, high and normal. Now, high, check. Humidity, see, I didn't draw the table, okay? That's why I want you to follow along. You trace it and then you'll be able to understand what we are doing. So, for humidity, for high, we had no, and for normal, we had yes. So, for high, it was no. We are done. Normal, it was yes. So, you see, this again are pure leaves now. So, we got another pure leaves. No further splitting, pure leaves. Practically, you know that what is left now is this last one. Again, we have attributes and gain value, and the gain value. So you see again, windy is the next node. So what I will do, I will update this now, right? So this is split, done. I will update this. So what comes in there is windy. So windy, we had two sub-attributes, which is weak and strong, or strong and weak, if you've made the table. So weak and strong. So for weak, it was yes, and strong, no. Weak, yes, and strong, no. So again, we have obtained pure leaves. So end of ID 3. End of ID 3 algorithm. So what happens now? Program terminates. We are done. Program terminates. Now, so if you are in doubt, I request you to please trace this again. Don't assume that you know it, right? See, the essence of taking pains and writing it on the board is to reinforce whatever you have learned. Please no shortcuts. Don't say, okay, I have it in my system, I will just study from there only. Please trace it, even if it takes you 2 hours to complete it. Keep going, provided you don't stop. Remember, I will leave you with this quote. Okay, it's not my quote, so I hope I have it. Right. So, it was a quote by Warren Buffett. And you know Warren Buffett is regarded as the wisest investor to ever live. Warren Buffett said something, and I quote, he says, an idiot with a plan can beat a genius without a plan. I repeat, Warren Buffett says an idiot with a plan can defeat a genius without a plan. Thank you guys, and happy studying.